Okay, so I have 2:00 p.m. Eastern Time on my clock, so let's go ahead and get started. Hello, everyone. Thank you for joining the Pre-Proposers Conference for Appendix E of the 2024 Human Exploration Research Opportunities, sponsored by the Human Research Program. My name is Guillaume Vigneault, and I'm supporting the review activities for the Human Research Program. And I will give you a brief overview of the new approach we use for reviewing the submitted proposals. But before that, Dr. Steve Platz, who is the Human Research Program Chief Scientist, will give you some background about the program and its goals for this solicitation. And finally, we will open for questions in the chat. Dr. Platz, whenever you're ready.
Thank you, Guillaume. I'm going to briefly turn on my camera just so you can all see me. Say hello.
Steve, you're muted.
Today we're talking about the Pre-Proposers Conference for the 2024 Human Exploration Research Opportunities, or HERO, and this is Appendix E. We have two flagship topics. Topic 1 is on EVA pre-breathe and exploration atmospheres, and topic 2 is on a venous thrombosis concern during spaceflight. There is no omnibus opportunity during this solicitation. Next slide, please. So the purpose of the Pre-Proposers Conference is to give you all more information, to get everyone on the same page, and to allow you to ask questions. This presentation is being recorded and transcribed, and you can access that after the fact. And any questions that are asked will also be archived. And if there are questions where we don't have an answer right away, we will answer that question and also submit that to the archive. So you'll be able to go back and look at all the questions and answers. The conference is open to all. We don't have restrictions on who can participate, and we hope that you all get the information you're looking for and have a successful proposal this next cycle. Next slide. So just a little bit about the Human Research Program. Our mission is to enable space exploration beyond low Earth orbit by reducing the risks to human health and performance. And we do this by working on 3 objectives. The first is that we perform the research necessary to understand and reduce these risks. This is what we're talking about now, doing a solicitation where we're asking folks from the community to write proposals, and we fund those proposals, get the information back, and then apply that to the risks. We also enable development of human spaceflight medical and human performance standards. These are things like radiation exposure limits, nutritional requirements, exercise requirements, things like that. We also develop and validate technologies that serve to characterize and reduce medical risks associated with human spaceflight. These are things like the ultrasound that's aboard the International Space Station. The current ultrasound is pretty small. It's about the size of a laptop, but previous ultrasound was very, very large. It took up an entire rack. It was heavy. And future ultrasounds will essentially be your cell phone with a probe attached. So doing this kind of development and characterization and validation is also some of the work that we do. Next slide. We do our work in what we call a stepwise approach. These are the stepping stones to Mars. The first is we do as much research as humanly possible here on Earth. These are in ground analogs. They're in laboratories. We have a bed rest facility that we utilize in Germany called NVHAB. We have research ongoing into Antarctica. We have several different isolation facilities. And we have the Space Radiation Laboratory at Brookhaven National Labs, where we do a galactic cosmic ray simulation. Now, you can't simulate everything here on Earth, and so we do as much work as we can in low Earth orbit on the International Space Station. When the station first launched, we did a lot of work just to try and understand what happens in low Earth orbit from a microgravity standpoint. What we're doing now is a lot of utilization of the International Space Station as an analog for spaceflight. So we're using it to predict the transit to Mars, to being on the Mars surface and being on the lunar surface. And finally, the third place is the moon itself. So I'm sure you've all heard of Artemis. This is a program designed to get us back to the lunar surface. And once we do that, we're also going to utilize the lunar surface as an analog for the Martian surface. And so, you know, there's a partial gravity environment on the moon, and we will utilize that to study as much as we can what we think will happen when we go to the partial gravity environment on Mars. Next slide. One thing that's very important for you all to know is that HRP is an applied research program. We are not NIH in space. We don't do much mechanistic work. We don't do basic science. There's another program here at NASA called the Space Biology Program, and they do a lot more basic science and mechanistic work. They do a lot of animal models and things like that. So if that's what you usually do, if that's your expertise, I would suggest looking at space biology as a place to get topics for your grant writing. In addition, we fund the Translational Research Institute for Space Health, or TRISH, and that's a cooperative agreement, and they're essentially our skunk works. They go out and beat the bushes for new technologies, different ways of doing business, and they also fund their own grants that are separate from this call. In addition, we work with pretty much everyone in the federal government, NIH, NSF, CDC, FDA, as well as other programs within NASA, and I already mentioned the Space Biology Program. Next slide. So within HRP, we're divided up into what we call elements. Each element has a slightly different focus. Exploration medical capability, they're looking at the future of medical care in deep space, and they also do a lot of the technology development, like I mentioned. Human factors and behavioral performance, they look at the interface between the human and the vehicle and the habitat, as well as doing individual and interpersonal behaviors and things like that, team dynamics. Human health countermeasures is the element that will be responsible for both of the topics that we're going to talk about today. So I'll invite Dr. Mercado to give you a little bit more detail on HHC. Becky?
Hi, thanks, Steve. Nice to see everyone here today. So my name is Becky Mercado. I am the Deputy Scientist in Human Health Countermeasures, or HHC, where we aim to understand the physiological effects to humans during spaceflight. And while we're looking at those changes, if they are deemed to be detrimental to either the astronaut during their mission or into their long-term health, then we develop countermeasures to those risks. In HHC, we have 3 very diverse portfolios, and both of the flagship topics today that we're talking about today will add research towards outstanding questions in the cardiovascular and the EVA risks. I'd also at this point like to introduce you all to Dr. Stuart Lee, our Associate Element Scientist, and when we get a little later in the presentation, he'll be describing the topics to you in more detail. Good luck, everyone.
Thanks, Becky. Space radiation is just what it sounds like. And as soon as I say space radiation, everyone instantly thinks of cancer. And that is one of their risks. But they also look at the biological effects of radiation on the central nervous system, on the cardiovascular system, as well as doing some of the cell and molecular biology work within HRP. And then finally, research operations and integration. This element's a little bit different. They don't solicit topics and have their own research, but they make everyone else's research happen. So these are the folks who work with the astronauts, they work with the schedulers, they work with the ISS program and other analogs. They do the scheduling, they organize the sample collections, and do all of that stuff that makes our program work. Next slide. As I mentioned, we have a number of venues where we conduct research. What's not shown here are laboratories across the United States. And so we fund about 200 labs across the US in 26 states. And there's a lot of work that's done right in the laboratory. But if your work does require an analog, these are the primary analogs that we use. So obviously the International Space Station. I mentioned NBHAP in Cologne, Germany. It's a really nice bed rest facility. The NSRL is at Brookhaven. We do sponsor parabolic flights where appropriate. The HERA is our short duration isolation analog, and that's located here at Johnson Space Center. And then finally, in Antarctica, we have multiple experiments going on in 2 different stations in Antarctica. Next slide. And so I talk a lot about risk, and it's really important to understand what we mean by that. So this is I know it's a really complex slide, but I want you to just start by paying attention to the left-hand side. It's a list of all the risks that have been identified by the Human System Risk Board. That's a joint board here at Johnson Space Center, where we look at the risk to the human and identify the severity of that risk. And they're organized by the hazard that's associated with that risk. So the hazards are radiation, distance from Earth, isolation and confinement, altered gravity states, and then hostile closed environment. And you can see all of those risks listed. Now, as we move to the right in these columns, each column is a different design reference mission or DRM. And you can see them listed across the top: low Earth orbit, lunar orbit, Mars, and then Mars planetary, etc. And within these columns, we assign a color to that risk. And that color has been agreed to by this Human System Risk Board. Now, a green color is a low level of risk, yellow is a moderate risk, and red is the highest level of risk. You can see as we move to the right, as the missions get longer in duration and further away from Earth, we go from green and yellow risks to more yellow with some red. And then finally, by the time we get to Mars planetary, we have mostly yellow and red risks. And so this is how we prioritize our work, how we decide what risks to spend money on, and also the scheduling that will happen with those solicitations. Next slide. As you can imagine, we have a number of risks that don't exist for other agencies like NIH and NSF. We have constraints on schedule. We do not schedule the launches and landings. We have limited crew access. We only have access to the USOS section of the International Space Station. So when we're talking about flight, that's about half of the crew who fly. And then beyond that, all human research is 100% voluntary. And so we have our experiments and we discuss them with the crew, and then the crew decides what to select, if anything, for human research. And so this creates a problem for us in that it takes us a very long time to get a sufficient N for statistics. And so because of this, we expect that any proposal written has a significant contribution to our risk reduction focus. You know, and this is another part where we're different from NIH. You know, in NIH panels, a lot of the discussion will be about the innovation brought to it, how different the proposal is, you know, what new technologies or new work is being done. That's not as much of a concern for us. The primary concern is how the proposal addresses our risks. After that consideration, then we talk about how innovative it is, what techniques are being used, and things like that. Next slide. So I mentioned how important statistics are to us because of our low N, and so we expect you to write an entire section, if you get to step 2, on statistics. We understand it's difficult to achieve ideal sample sizes, but you must do analysis for statistical power. You have to tell us how you're going to control your variables and how you're going to do your analysis. This is a very important part of your proposal. Don't skip it, because if you skip it, your proposal will not be evaluated. Also, because it's so important, we make sure that on our review panels, we have at least one statistician on the panel to judge the statistical section. Next slide. We also expect you to consider sex as a biological variable. It must be factored into your research design and your analyses, and this is regardless of what vertebrate animals you propose to use. If you propose to use mice, if you propose to use humans, you must address sex as a biological variable. It would be very rare for someone to propose only using one sex and to have that accepted by HRP. For ground-based studies, this is especially important. For flight studies, we understand it can be difficult to get an even distribution of males and females. That's out of the control of the investigator. It's out of our control, but we expect a good faith effort to be made to balance as well as can be done. Next slide. Dual anonymous peer review is a relatively new process that we undergo. So not only will the proposers not know who the reviewers are on the panel, but the reviewers on the panel will not know who wrote the proposals or what institution they're from. I can't stress strongly enough how much you should read the solicitation for all the details on how to do dual anonymous peer review. If you send in a proposal that you wrote a couple years ago because the topic is appropriate, but you don't make changes, it will be returned. It will not be evaluated because those proposals do not fit the correct format or requirements for dual anonymous peer review. If you've never written one with dual anonymous peer review before, we have a workshop coming up August 22nd, and I encourage you to dial into that and listen and ask questions. And on this slide, and this slide will be archived, so you'll be able to access it, we do list commonly observed pitfalls to avoid. Next slide. So now we're going to talk a little bit about the two specific topics, and I'm going to defer to Dr. Stuart Lee from the Human Health Countermeasures element. He's going to tell you a little bit more about these two topics for research. Stuart?
Good afternoon, everybody. Thanks for coming to listen to our pre-proposers conference. Hopefully this will provide you with some good information as you start putting your research teams together and hypotheses. We have two topics this go around. You'll notice in each one of them, there is a definition phase. If for proposals that are selected, we take the first year to kind of work out the logistics with you, gives you a chance to get your IRB information sorted before you start collecting data. And then thereafter that, we have an implementation phase. It's an important step, that first part, particularly for flight studies, where we do a feasibility assessment. If we're sending something to spaceflight, the ROI group, research operations integration, that element that Steve mentioned before, will work with you and see whether the study can actually be done on orbit. There is when you go through this process, the definition phase, if it's deemed feasible, then we proceed to funding for the following years, and you can see the amounts that are listed here. It's important for you to understand that we don't actually move into the implementation phase until NASA gets concurrence, or NASA provides concurrence, excuse me, on moving over to the implementation. So next slide, please. So our next slide, or our first topic, excuse me, refers to research that we're looking to do in the mitigating the risk of decompression sickness during EVAs. As you're all probably well aware, the station currently runs at atmospheric pressure, sea level equivalent, 14.5 psi and 21% oxygen. But when we go into the suit, the crew members actually, we decrease the pressure in the suit so it makes it easier to move. And so this creates a potential for decompression sickness in the crew members. We've not had any reported instances on orbit, but there always is some amount of risk. And one of the challenges with mitigating this right now, although we have pre-breathe protocols, they are kind of long, and any length of time that you spend performing a pre-breathe starts to cut into the time that one can use to perform an EVA. Our crew members have, constrained duty days to make sure that they're able to perform well. And so the intent is to be able to decrease the pre-breathe time while increasing the efficiency and the safety. This proposal is a little different than the one that you might write up from your single institution. This proposal is set to use what's called a virtual NASA Specialized Center of Researcher, VM score. You'll hear that acronym bandied around from time to time. Basically what it is, it becomes a virtual team of experts who will work on this particular topic. There will be, from the proposals, NASA will select probably the top 3 or 4, and one of the team members will be the lead, the one that organizes the whole team. The objective is to standardize the data collection and the methodologies and the measurements such that from this effort, the team as a whole can generate a model that would predict the risk of DCS type 1 and type 2 for our different pre-breathe protocols. So what we're asking is that the teams that are proposing, you're looking at DCS mitigation protocols and nominal conditions, probably in human trials, and also potentially in animal trials, DCS mitigation in emergencies or rapid depress would be a concern, for particularly when we're talking about long duration missions. How quickly do we need to get crew members into a suit, and what mitigation strategy we might use from there. In the process of putting this all together, NASA worked very closely with a team in that the early phases of the study. We will have subject matter experts on our side who will provide the core measures that will be expected, but we also encourage the investigators to propose new biomarkers or technologies that would improve the sensitivity or the specificity of the model that will be developed. The end goal is essentially a dive table that we would use for EVA. So what we're hoping you will do is, as a team, develop this tool that we can test out. That's really the deliverable at the end. We want to be able to potentially use it in our NASA operations to demonstrate its utility. And of course, with all our projects, we expect you to, provide reports particularly a final report to the HRP and archive the data, as well as provide copies of any peer-reviewed publications or presentations that result from the study. So I just want to make sure that I'm clear about how I described that. each team or each proposal should propose the work that they intend to do, their expertise. If so you might be proposing a particular pre-breathe protocol, some other way to decrease that pre-breathe time while maintaining safety. If you are interested, you also may propose to be the lead. And we're expecting that the lead team will also be the one that would be in charge of the modeling, pulling all that data together to create a single model, single dive table. So next slide, please. This one's a little less complicated. This is not a Venn score. This is our standard proposal structure. You're probably all well aware of the reported venous thrombosis, thrombus in the left internal jugular vein. That is an incidental finding in one of our experiments that was not looking for that. It was actually examining fluid shifts and how that might affect other systems. There also, we reported a second case that we discovered on retrospective review of the images from that particular study. It was a partially occlusive thrombus, but because we did not see it on initial, we could not confirm it using normal clinical standards. One of the particularly concerning parts of these is that both were asymptomatic. And so it raises the question when we're talking about safety of our crew members, have there been other cases of which we have been unaware because there were no complaints or no signs or symptoms that would suggest that we had a thrombosis case evolving. So to that end, this is one of our major risks going forward with concerning health. So what we're hoping people will propose for us will be methods to characterize the risk of venous thrombosis using standard or advanced imaging techniques and diagnostic practices. There is also opportunities to consider data mining, analyzing archive samples, and things of that nature. We are not closed to the idea of using analogs. We've used those in the past. We've just been in the last couple of years we've done some parabolic flight studies. But importantly, we want to improve our approaches to screening, monitoring, and making clinical decisions, particularly when we're talking about doing exploration missions beyond low Earth orbit, in which the ability to treat these in a normal fashion would be limited. So what we're looking for is a characterization of the risk of venous thrombosis in spaceflight. We want to develop a standardization of data collection and protocols so that we can put all this information into the NASA Life Sciences archives appropriately and make it available to others in the future who might be doing similar work. I would note here that NASA does already have, in response to those two cases, NASA has implemented a surveillance program, and we have not detected any more cases in that surveillance program. And to understand what that is, obviously we gave you a good list of references, but I would call your attention to the paper by James Pavello, and who's one of our flight surgeons, to understand what that piece is. So with that, I hope I was helpful in describing this to you and giving you some information, and we look forward to just hearing or seeing your proposals.
Thanks, Stuart. Before I let you go, though, there's a question in the chat, and maybe you could discuss this just a little bit more one more time. The question is, where did it go? Must proposers be part of a team before submission, i.e. proposers cannot propose individually? Can you address that just a little bit more?
If that's in reference to the VIN score, no, you do not have to be part of the larger team. You would write a single proposal for the work that you would do to aid in the DCS risk. And then NASA would select the proposals that would go forward to form the VIN score team. The venous thrombosis is a standard proposal, so you would be a single proposal or institution making the proposal.
Great, thanks, Stuart. Next slide, please. Again, I already mentioned some of the program constraints that we have. Must be risk focused. You must address one of these two topics. So if you put in a proposal that's talking about radiation or sensory motor or something else that doesn't specifically address these topics, it will not be reviewed and it will be returned as non-compliant. So please make sure you focus on these two topics that we're presenting here. As I said, there's no omnibus appendix with this particular call. We have very limited resources. Let's see, and then next slide. So some key dates for everyone to know. We're doing the DAPR workshop, Dual Anonymous Peer Review, on August 22nd at 10 a.m. Eastern Time. If you've never written one, or if you've written one and it's been returned, I would highly suggest that you participate in this workshop. If you don't attend, send a student or a postdoc and make sure you get that good information, because we're very strict about the dual anonymous peer review requirements. If you do one little thing wrong, we will not evaluate your proposal. Step 1 proposals are due on August 26th. Step 2 proposals, that's not correct. Lishar, what's the date for step 1 proposals when they're due? Is that October 26th?
Step 1 proposals are the step 2 proposals after invitation. I believe that is correct.
So step 1s are due August 26th?
That's
Correct.
correct.
Yes, step
So
1.
12 days?
Yeah.
Okay. Okay. And then step 2s are due November 22nd. And
That's
the
following
selection
invitation.
Yeah. And then the selection announcements will be made in April. Next slide.
That was your last slide, Steve.
What's that?
That was your last slide.
Okay, great. Thank you all very much. Like I said, if you have questions, you can either wait till the very end or you can put them in chat and we'll make sure we get to them all at the end of the discussion. Thank you.
Thank you. So before we start answering questions, you can, of course, continue to post them in the chat. But before we answer them, we'll go through a very quick last presentation, which will be focused on the new approach HRP as a human research program used for the last couple of years. And especially, so the implementation of DAPR, dual anonymous peer review, as Dr. Plas mentioned, this presentation will be a very brief overview with key points. But please, I would highly encourage you to attend the DAPR workshop that will take place on August 22. You can find the meeting information for this meeting posted alongside the solicitation. So with DAPR, reviewers will not see any information that would identify proposers during the first part of the review process. In order to achieve that, proposers must follow the instructions provided in the solicitation, as well as in the 2024 ERO overview document posted alongside the solicitation. And posted in Inspires as well, you can find a DARPA guidance, which further expand on the proper preparation for a proposal to follow, to be compliant with the DARPA requirements. Since the submission process is a two-step process, most of the following information apply to step 2 proposals, but it's a good way to wet your feet a little bit into the process before writing your step 2 proposal. So why dual anonymous peer review? So a key goal of peer review is to level the playing field for everyone. We know it's difficult to completely interrupt biases through training alone, and it requires structural changes. And that's why DARPA aims to create a change in the tenor of discussions away from the individuals on the proposing team and towards the proposed science. DARPA is not completely a blind process. Proposers submit an anonymized proposal and a not anonymized expertise and resource document. The merit of the proposal assessed anonymously will be determined separately from the non-anonymized qualifications of the team. Nevertheless, the qualifications, track record, and access to unique facilities will form part of the evaluation. So to submit your anonymized proposal, please exclude names and affiliation of the proposing team, including in figures and references to personal websites. For references, use numeric format only, and do not claim ownership of past work. So for example, my previously funding work is not acceptable and can be and should be replaced by something like our analysis shown in Baker et al. 2012, etc. Also cite references in the passive third person. For example, prior analysis reference indicates that blah, blah. Do describe the work proposed. So for example, we propose to do the following, or we will measure the effects of. Also include a separate non-anonymized expertise and resources document. So how to reference unpublished works or proprietary results. So HRP is aware that it may be occasionally important to cite exclusive access datasets, non-public software, unpublished data, or findings that have yet to be presented in public before, but are not citable. Each of these may reveal or strongly implies the investigators on the proposal. So in these instances, proposers must use language such as obtained in private communication or from private communication when referring to such potentially identifying work. Please recall that the goal of DARPA is to shift the tenor of the discussion, not to make it absolutely impossible to guess the team members. So during the review and during the panel discussions, there will be two phases. The first one is the science review. Each proposal PDF will be assessed based upon significance, mitigation of risk to crew health, approach, and statistical plan. And during the second tier of review, the expertise and resources will be evaluated. And this will take place after science review using the separate non-anonymized PDF you will be provided. Proposers are assessed as qualified or unqualified. So the expertise and resources review phase may not be used by the panel to reevaluate proposals or to change the assigned adjective grade. So final words, again, HRP is aware that it may not be flawless. We are observing and analyzing the other programs as they adopt and adapt DARPA approach to peer review. and formal support in Inspire is implemented but still new. Nonetheless, DARPA represents a major shift in the evaluation of proposals, and as such, there may be occasional slips in writing anonymous proposals. However, NASA reserves the rights to return without review proposals that are particularly egregious in terms of the identification of the proposing team. NASA further acknowledges that some proposed work may be so specialized that despite attempts to anonymize the proposal, the identities of the principal investigator and team members are readily discernible. As long as the guidelines are followed, NASA will not return this proposal without review. But DARPA has promised in increasing the focus on science during reviews and reducing bias, and that's why HRP is moving forward to this new process for peer review, and we have high hope for that DARPA to improve the review process and toward a focus on the science and merit. So that's all I have. So now we can address as much question as we can, and any questions that will not be answered will be addressed in a FAQ document that will be posted alongside the solicitation within the next couple of days. So let's see which question we have. I see a question. In the risk chart, the VTE row did not have any color indication, but not applicable. So is this information meant to be ascertained by way of the response to the solution topic 2?
Stuart, do you want to address that?
Yeah. So one of the things, I apologize, it looks like that risk chart is a little bit out of date. There are some things that need to be updated, but it is the venous thrombosis risk actually falls now on what's called the cardiovascular risk, and it is yellow for all of our design reference missions in mission, but I would use the information in the solicitation itself for your background, and we will be sure to provide you with an updated chart at least in the FAQs.
Thank you, Stuart.
Next question. Would a virtual company with strong university or research partners be eligible for this program?
I think that one's been answered in the chat.
No, the one before was answered. Can private for-profit organization apply?
No, here's Manisha answered it. Virtual company is fine as long as it's registered in sam.gov.
Then, if proposing technologies, specifically bio-wearables, are there additional safety certification requirements, or would safety certificates from the NAVSEA fleet safety testing be sufficient?
If it's something that you intend to fly, it would have to be flight certified, and the ROI group would work with any proposers on getting that accomplished.
Will there be another round of pre-proposals for high-risk HRP studies?
That's been answered.
Yeah.
Twice.
Yeah, I see the answer later. Sorry. I think this one wasn't answered. Apologize if it did. Would there be another solicitation opening up in near future for research related to human factors and behavioral performance?
Yeah, answered.
Oh, sorry.
No worries. No worries.
Should commercialization of the proposed technology be included in the proposal?
That is not a requirement. This is not SBIR. So we're more concerned about how you're going to address the risk than what technology is being developed for it.
Proposers should not make reference to their past work, but is the background research of the proposer not a factor in evaluating the proposal?
So that one's not quite.
Yeah.
So that I think the question is starting on a slightly false premise. You do want to discuss the work, but in your proposal, you do not write, as we have previously shown, or from our previous work. You would just say, it was shown that, and you will use the correct reference format, which does not include your name. It just includes the number of the reference. And then the panel will review just on the science content. Once they have given a science score, they will then be unblinded and they will get to see the proposers' names and the institution and all of that information, the full reference list and everything. And then they comment on the credentials of the proposers. So it is part of it. I wouldn't not reference work you've done before. Just make sure you reference it properly with the correct verbiage. And that is given in the slide as an example. And we will also talk more about it in the DAPR workshop.
And the last question I see has just been answered. So I will read the question, the answer, and if anyone wants to add anything, please do so. So the question was, are proposers expected to use NASA-supplied analogs, or if the proposers have habitats or pressure chambers, can we utilize those? If we can use our own facilities, can we exceed the 3 chambers runs specified in the topic 1? And Becky replied, you are welcome to propose using alternative chambers. Those must be included in the budget within the limits stated for the topics. Would you like to add anything to this response?
Nope, I think that was a good response.
Okay. And we have a few additional questions now. Is there a word count for the step 1?
It should be listed in the solicitation.
Yeah.
Read it.
Should a novel device developed for disease, parentheses, DVT, detection focus more on the device or the testing strategies in flight analogs?
You should focus on how you're going to mitigate the risk that we've asked you to mitigate. If you only focus on the device, that's not what we're asking for. We want you to tell us how that device is going to help us understand and mitigate the thrombosis risk.
Is this proposal open to other government entities or partnerships?
I believe it is. I know that other organizations within NASA will respond to the solicitation, so I don't see why other government entities couldn't.
And the last one for now is gene profiling an accepted means to diagnose presence of DCS or venous thrombosis during the flight mission?
Stuart, you want to try that?
So we are looking for more information about how we can predict who will develop either of those. During the flight would be challenging, based on the technology that would be needed. If you have a means to do that, certainly gene profiling opens up a lot of doors. Privacy concerns, particularly when we're talking about astronauts, there's so few of them. We have a heightened awareness of that. So it would, I'm not really sure the correct 100% answer, but I would say that whatever you would propose would need to be very targeted. But we can give you a better answer later.
And that was the last question I can see on the chat for now. So we officially still have 10 minutes. So maybe we can give you a few more minutes for last minute questions, if you have any. Just one more question. Is there general interest in developing a procedures for biomarkers identification and/or biological pathways in EVA astronauts?
Not as part of this solicitation.
I think I want to go back briefly to the question about devices. I don't think we're not looking to essentially fund a startup or something like that. We're looking to find something that we can implement fairly quickly because ISS there's not that many more years that we're going to be flying ISS. And the next steps, are obviously private space stations, but we would like to solve or understand this problem before we get to the end of ISS. So, developing a new device and then trying to get it flown to verify that it works is not a short process. I think what we're really looking for is something that we can implement in a relatively short amount of time.
There have been tissue bubble dynamics models to calculate the bubble growth index and the probability of DCS from the bubble growth. Does the community think there is need to include partial gravity in these estimates?
That is one very specific topic that has come up in our expert panels, that there is a belief, a concern that the likelihood of bubble formation and DCS will be higher because we're now moving from, primarily upper body arm movements in the EVA suit now to ambulation and doing more physical work. So yes, that is a concern.
Okay, so I don't see any more questions coming. So if you agree, Steve, I think we can adjourn.
Yep, sounds good. Thanks, everyone. We appreciate it.
So thank you very much, everyone. As a reminder, the recording of this meeting, as well as the presentation slide, will be made available to you and posted on Inspires alongside the solicitation within the next couple of days. This is also true for an FAQ with all the questions and answers. And we look forward to see you at the DARPA workshop on August 22. Thank you very much. Have a wonderful rest of your day.